Welcome. I am Professor J. N. Mandal, Department of Civil Engineering, IIT Bombay. The name of the course is Geosynthetics Testing Laboratory, and this Geosynthetics Testing Laboratory we have in IIT Bombay have two courses, that is Reinforced Earth for undergraduate student C492 and the postgraduate course on geotextile CE746, and this course is running since 1984 at Indian Institute of Technology, Bombay. This module 1, the lecture number 1, I will discuss the physical properties of the geosynthetics material. The outline of the course, I will discuss about the content of the course and I will provide some references. In this geosynthetics testing laboratory, we will cover the chapter, module, content and the number of lecture. So, in chapter 1, we will go for physical properties of geosynthetic material, and module 1 is mass per unit area, thickness of geotextile and the specific gravity. This is mechanical properties, that is strip and Y-joint tensile strength. Next, chapter 5 is trapezoidal shear strength. Chapter 6 is drop contest, penetration modulus resistance. Chapter 7 puncture resistance test. Chapter 8 brush strength. Chapter 9 graph strength test, and chapter 10 pull out resistance test, and chapter 11 strain seam strength. Next is chapter 12 is hydraulic property, that is cross plane permeability, which is called the permittivity, and chapter 13 module 3 in plane permeability or transmittivity of geotextile. Chapter 14 apparent opening size, and chapter 15 is the porosity. Next, we will discuss the endurance properties of geosynthetic material. Chapter 16 is module abrasion test, and chapter 17 gradient ratio, or which is called clogging test. These are the some tests on the geofoam material, which is superlight material. For chapter 18, we will give the density of the geofoam material. Chapter 19, water absorption capacity of the geofoam, and chapter 20, that compression test of the geofoam. Chapter 21, tensile and shear behavior of the geofoam, and chapter 22, flexural properties of the geofoam material. Chapter 23, flammability test on geofoam. So, these are the tests generally we will perform, and main target audience for this course will be very useful to undergraduate, postgraduate student and research in civil engineering, earth science and geology and the textile engineer, consulting and the practicing engineer, government official, policy and the decision maker, implementation and NGO, professor, specifier, project designer, distributor, textile engineer, contractor and manufacturer. The prerequisite for this course in viewer should have some knowledge of the basic geotechnical or soil mechanics and the geosynthetics engineering. I am giving some of the references for this course. So, you can go through some of the book, this Mandal Jain and Deepsikar DG 94, a guide to geotextile testing, this Oxford IBH Company Private Limited. You can also follow the ASTM D5261, that is standard test method for measuring the mass per unit area of geotextile. ASTM D5199, that is standard test method for measuring the normal thickness of geosynthetics. ASTM D792, that is standard test method for density and specific gravity or relative density of plastic by displacement. ASTM D1388, that is standard test method for stiffness of the fabric. ASTM D4751, standard test method for determining apparent opening size of the geotextile. ASTM D6241, standard test method for static puncture strength of geotextile and geotextile related product using a 50 millimeter probe. ASTM D1682, standard test method of test breaking load and elongation of the textile fabric. ASTM D6706, standard test method for measuring geosynthetics pull-out resistance in soil. ASTM D4884, standard test method for strength of shear or the bonded seam of geotextile. ASTM D4491, standard test method for water permeability of geotextile by permittivity. ASTM D4716, standard test method for determining the in-plane or flow rate per unit width and hydraulic transmittivity of a geosynthetics using constant head. ASTM D4886, standard test method for abrasion resistance of geotextile, sandpaper or sliding block method. ASTM D5970, standard test method for determination of geotextile from outdoor exposure. ASTM D5101, standard test method for measuring the filtration compatibility of soil geotextile system. ASTM D5567, standard test method for hydraulic conductivity ratio, that is HCR testing of soil / geotextile system. ASTM D4595, standard test method for tensile properties of geotextile by the wide width tip method. ASTM D4533, standard test method for trapezoidal tearing strain of geotextile. So, these are the specification which we will follow during our geosynthetics testing laboratory. So, one should read these books and the specification. Apart from this book, you can go one of the book, that is Geosynthetics Engineering in Theory and Practice, and that has been published in the research publisher in the Singapore. Now, what is geosynthetics? A planar product manufactured from polymeric or natural material used with soil or earth as an integral part of man-made project structure or system. And this include planar structure, geomembrane, geotextile, geosynthetic clay liner, barrier, geonet, geogrid, geostrip, geospacer and the geomat, etc. and three-dimensional structure like geocell, geofoam, gabion and concrete fill matrices. Now, there are defined types of the geosynthesis material available in the world. It is about more than 1000 different types of prefabricated geosynthesis material are available. The sum of the geotextile material are presented here. This number 1 is the geotextile. This is designated as GT. Then geogrid, this is designated as GG. This is geonet, this is designated as GN. This is geomembrane, this is designated as GM. And geosynthetic clay liner is designated as GCL. Geopipe is designated as GP. Geofoam is designated as GF, and geocomposite is designated as GC, geocell and the geoweb. So, these are the defined types of the material. Here I am showing some of the geosynthetic material. There are two types of the geosynthesis material. One is the woven geotextile material, another is the non-woven geotextile material. So, when you say it is the woven geotextile material, you can see here this geotextile material, these filaments are perpendicular to each other. I am showing one of the woven geotextile material, this is the woven geotextile material, and these of the filament are perpendicular to each other. So, it is called the woven geotextile material. This woven geotextile material, we have to determine what should be the tensile strength of the woven geotextile material and the corresponding the elongation and some other test. So, this is a kind of the woven geotextile material. This geotextile material made of polymer material. You can also develop this woven natural geotextile material. This is woven jute geotextile material. Here you can see these filaments are perpendicular to each other. So, it is woven jute geotextile material. So, it has also the tensile strength in the machine direction and also cross machine direction and corresponding to the elongation, what we will study. So, this geotextile material is the woven geotextile material. We have a non-woven geotextile material. This non-woven geotextile material, when the filament is very random like a blanket. So, these are the non-woven geotextile material. I can show you some non-woven geotextile material. This is non-woven geotextile material. So, his filament is very random. So, you have to perform what will be the tensile strength in the machine direction as well as in the cross machine direction, and what will be the elongation for both machine as well as cross machine direction. You can also perform the test in the diagonal direction. So, this is the non-woven geotextile material whose filament are very random. So, this is the natural non-woven geotextile material, and this geotextile material is made from jute fiber. So, natural material also used for the as a geotextile material. So, this is the non-woven natural jute geotextile material. So, most of the cases that this material can use as a filtration and the drainage material and as well as reinforcement. Next, this is the geogrid material. So, this material have a uniaxial geogrid and also the biaxial geogrid. uniaxial geogrid and also biaxial geogrid. This is the uniaxial geogrid. Okay? And this acts as a reinforcement, and you have to determine what will be the tensile strength in the machine and cross machine direction and corresponding to the elongation. And this kind of the geogrid material can be used for the construction of the reinforced soil retaining wall or the reinforced soil slope. And also you can use for the geogrid material for the road construction. And this is the uniaxial geogrid material. This is biaxial geogrid material. This is biaxial geogrid material. So this also can be used for the railway. It has also the tensile strength in the machine and cross machine direction and corresponding to the elongation. There are some other material also used for the construction of the reinforced soil retaining wall, and this is what you call the friction tie. So this kind of the material also can be used for the construction of the reinforced soil wall, and it is called the friction tie. You can use some material for the reflection cracking. So this is a kind of the material which you can use for the reflection cracking material. It has been used also in the airfield pavement for the reflection cracking, and it has strength also 100 kilonewton per meter or 50 kilonewton per meter. So this is all glass polymer material. So this geogrid material is used. This is uniaxial geogrid. That's I showed you that biaxial geogrid. There are another also new material has come, which you call the triaxial geogrid material. And this triaxial geogrid material also is made from the bamboo and also polyester material. This is geonet material, and this is the rhombus in shape. This is the geonet material. This geonet material is used for the drainage and the filtration. You can use for the landfall. Where there is a problem with the drainage and the filtration, you can use this kind of the geonet material. All the earlier material, all the material are permeable material, and all are polymer material and also the natural material. Now this is geomembrane material. So this is impermeable material. It is like a rubber. So you can use this kind of the geomembrane for the landfill. Also you can use for the earthen dam to control the seepage, for the canal liner, for the reservoir, you can use this material. And this geomembrane material, I am saying this is the impermeable material, and in this geomembrane material you can see both the sides are smooth geomembrane material. This smooth geomembrane material. So if we want to use in a slope of the landfall, and then you sometimes require there will be the mobilization of the friction between the slope soil layer and the geomembrane. And that is the why that there are some geomembrane material also developed. The one side of the geomembrane is very rough, which can be faced toward the slope of the soil, because there will be a development of the friction between the rough of the geomembrane side to the soil, and the other side is the smooth. So you can develop any kind of the geomembrane material, either smooth on both the side, or one side is the rough and another side is the smooth, depending upon the type of application. Wherever you require the mobilization of good friction between the soil and the geomembrane, then you can use the rough geomembrane material. So these are the all impermeable material. This is another exciting material also. This is geosynthetic clay liner, and this geosynthetic clay liner is made of geotextile, bentonite and the geotextile. It's like a sandwich form. So when the water will come in contact with the bentonite and it expand and it act as a impermeable material. I will show you that some material, this is the material which is that GCL or geosynthetic clay liner. It may be the oven bentonite and the non-oven or oven or geomembrane, any combination. So you can use of this geosynthetic clay liner as a impermeable material, and this is alternative to the geomembrane material. So you can use also in the landfill, and geopipe, as you know, we use it. So this is one of the exciting material which you call the geofoam, and in textile term, it is called the expanded polystyrene material. And you can have with the different size and shape and the different density this geofoam material. This is, you can have it different shape and size with the different density of the material, and this is the geofoam. It is nothing but a thermocol which you take a cup of coffee or tea. You can have the different size and shape and the density. And this is the block, you can have it in the 2 meter by 500 millimeter by the 300 millimeter, and this weight about 36 kg. You can simply placed for the construction of embankment onto the soft soil. So one should know what should be the characteristics of the geofoam material. So this is a kind of the geofoam material, and its density is about 100 times less than the soil. So it has a lot of potential use for the construction of embankment or soft soil, or you can use at the back of the retaining wall to reduce the lateral pressure drastically. And this is the geocomposite material. All the material what I told, that geotextile, geomembrane, oven and non-oven geotextile material, geogrid, any combination of geogrid, non-oven, geogrid, oven material is a geocomposite material. Geonet or the non-oven geotextile material also is a geocomposite material. I will show you some of the geocomposite material. This is the geocomposite material. Okay, this is non-oven and the geonet material and the non-oven. So this is the geocomposite material. You can have also, this is also you can say geocomposite material, and basically this is the material which we use for the ground improvement. When the ground is very soft, so we use generally the sand rain, and it takes time to consolidate it, maybe 2 years, 7 years, 21 years. Alternative to the sand rain, you can use, this is prefabricated vertical band rain, or which is called popularly known as the PVD. This is also geocomposite material because this is the core material and the other side is the jacket material, and this is the non-oven span bonded geotextile material, and this is the core. So you can insert it into the soft soil, there will be distribution of the pore water pressure and is channelized to the channel. So this kind of material also will perform the test, and also we should know that what should be the quantity of water can pass through this material and what will be their tensile strength and other property. So this also you can say as a geocomposite material. We can have also different types of the geocomposite material, span bonded non-oven geotextile material and plastic core. And then also we can say the natural material also like a PVD, the outside is the oven and non-oven jute material and coir coconut fiber. This act as a flow of water. So, this is the jacket and this is the core material. You can use also this kind of also as a geocomposite material. This another material which you call the geocell. So, this is the geocell, this is a hexagonal 3-dimensional hexagonal structure. So, this geocell or the geocell you can be collapsed, it can be expanded and it can be filled up with the defined types of the filling material, gravel, sand, and place it and compact it. You can construct the road, you can use for the slope, you can use for the erosion control. It has a lot of potential application of geocell material in civil engineering. So, what are the major applications? That is geotechnical engineering, transportation engineering, geo-environmental engineering, hydraulics or ocean engineering, earthquake engineering, mining engineering, agricultural engineering and bioengineering. So, these are the major material what I have shown you. It is a woven and non-woven geotextile material, and how we can make use all this kind of the material in the different engineering system. It may be transportation engineering, it may be environmental engineering, hydraulic engineering and mining engineering, agriculture and bioengineering. So, this will be very helpful for the use of the geosynthetic material in different projects. So, we should know that what should be the exact properties of the geosynthetic material required for certain application. Thank you.